Yeah. So starting with, welcome everyone. Thank you for staying till the end to attend this talk, and we'll try to be as brief as possible and teach you ways of becoming a millionaire. Before we start off, I'd like to introduce of who we are. My name is Himanshu, and I've been into the field of bug bounty since, I don't know, last 10 years or so. I started back in 2009. I was playing bug bounty for Yahoo, Google, Facebook, LinkedIn, Pornhub. So, yes. Then I've written a couple of books, one on Red Team, two on Kali, one more is coming on Metasploit. And I have I've co-founded bugsbounty.com. And what we do is pure red team simulation. So it's like, unlike you guys, we do not have GDPR yet. So we have CISOs approaching us, and we get targets. So CISOs come to us and they tell us, oh, okay, these are my 10 investments. I have done all the pen tests. I have external vendors. I have internal vendors. I have done multiple audits. Can you guys come now and check whether can we be hacked? And if an attack is happening, will my team be able to detect it? So that's our job. That's where we come in. My whole team, we just go sit in one night, and we do the entire black box starting from scratch. And we don't stop until we get what's the main goal, the vault of the company. So starting off.
Yeah. So to introduce myself, my name is Aman Sachdev, and we both are co-founders of Bugs Bounty, as he told you about. And as you can see, we talk security, walk security, and especially eat security from my perspective. But to give you just a base idea, I'm a developer at heart. Started out as a developer, Java, PHP, and all that standard shebang of C++. Later out turned my interest towards hacking, and now my core job includes carrying out social engineering and phishing campaigns, and doing all kind of red team stuff, bypassing firewalls and any kind of technical things that require exploitation, bypassing of AVs, and whenever the team gets stuck at some point of exploitation, I go and see what can be done. So that's what I do. And
let's look at three ways of becoming a millionaire.
So the question is, how do we become a millionaire, right? So we'll ask you questions. There will be 4 options, 4 lifelines. Oh, it's not that difficult. So the ways are, either you save money, all right, or you steal money, or you have some interesting services in your country, right? So save money, I don't think I'll have to help you with saving money. But coming to when we talk about stealing money, let's see what we can do. So when we talk about stealing money, we have various targets, right? We have direct money sources and sinks. Direct money sources where the money is there, right? The banks, all right? Mobile wallets, credit cards, cryptos, and all that. And then we have indirect money sources and sinks, which is like anything which is indirectly related to money, which is like shopping or online services, that kind of stuff, right? So apart from that, we have information and data which can be monetized. For example, how many of you have bought credit cards in the underground market? Please don't raise your hands. Right? We know what rate they go by. You can sell data. There's a lot of things that can be done without actual money, but people involved with money, right? So these are some 3 ways of gathering money. So what can be done with these targets? When we talk about the direct money sources, we can steal and move money from banks. We can move it from one account to a different account. And with indirect money sources and sinks, we can maybe purchase stuff from free, avail some services for free, bypass some payments, pay our loans and policies and whatnot, right? And as we talked about with the last one, the data can be sold to interested parties. Now the question is how? We'll start with indirect money sources, that is online services and anything that deals with online payments. And from what, we have been bypassing payments and all that kind of stuff since very long time as part of our general exercise that we do with Bugs Bounty, which is being the watchdog of the organization and doing all kind of black hat approach towards their security. And these are some points that we have realized I don't mind you taking screenshots of these. These are basically the steps or the kind of implementations that can be bypassed and we'll see some of the scenarios over here. So let's check out the first one, which is amount tampering, right? So this is the case wherein you make a purchase on a website, and this is like we're talking about old eBay bugs, if somebody remembers, the €1 bug, when you change the amount to €1 and say not at the cart, but when it is being sent to the payment gateway. So you place an order for, let's say, €50. The request goes from the shopping website to the merchant. And when it's going to the merchant or the gateway, you intercept the request, you change the amount from 50 to 1, and the transaction, you go and pay for €1. The bank responds with a success, saying €1 is paid. The website sees, okay, it's paid, and the order gets approved, but you only paid €1. Right? This is the old stuff, right? It used to work a lot. Nowadays, does not.
We did the same for, this was the case of a bill payment on the electricity company. So we had free access, basically not free, but very cheap electricity.
Yeah, so, €500 to €5. This was possible with these kind of flaws. All of these screenshots are captured from our live targets. That's why they are blurred. But what I'm saying is these flaws actually exist. And a lot of times you can tamper with the amount, either when it's going from the website to the merchant or from the merchant to the gateway or somewhere in between this entire process with middlewares. But interesting case scenario is secondary parameter poisoning. In this case, this was like an Uber for trucks. So this service runs in Asia, quite popular, wherein you can hire a truck to move your stuff, right? Now these guys, they made the entire platform on Ruby on Rails, and all the technical flaws that you generally look for, the OWASP, they were simply not there. Because Ruby on Rails by default hardens a lot of standard vulnerabilities like XSS, SQL injections, and a lot of kind of stuff. So here we try to find logical vulnerabilities, and in this case, when I failed tampering the amount parameter, it didn't work. Obviously, they were having some checksums and all that. What happened was, I saw this interesting parameter. I don't know if you can see it. It says toll. So when you cross a boundary, you have to pay certain toll tax, right? So this toll, what I did in this was, I simply passed minus 1,000. The formula says, the cost of the trip plus the toll tax equals to the resultant. Now, the toll I provided was negative. Resulted, the driver sees 0. The driver has to collect €0. So this was a very interesting scenario wherein standard tampering in the amount might not work, but you should always look for formulas. There was very interesting case scenario with one of the biggest pizza delivery applications, wherein you could just place an order and set the quantity to 0.1. Let it settle in. When the person receives the order, he says, what's a 0.1 pizza? Must be 1 and a dot. Some problem in the printing. Sends 1 pizza. He cannot send 0.1 pizza, right? But the price you pay is cost into quantity, and quantity is 0.1. So you end up paying 1/10 of the money. So these kind of secondary order, second parameter poisoning is another technique that is pretty common that you should test for.
So now to prevent this, I guess most of the payment providers and websites, they have a checksum in place so that nothing can be tampered with, right? So what do you do when there's a checksum? Well,
yeah. So
you bypass it.
So let's see if we can, let's see what we can do if we see if there is a checksum on the website. I guess everybody understands what's a checksum. You take all the parameters that are going through a request, you calculate a hash out of it using some kind of one-way algorithm, maybe MD5 or SHA-1 or SHA-256, Bluefish, whatever. You calculate that, send that across, and the server does the same. Server calculates the hash, and if the hash is matched, the request is accepted and assumed that no tampering has been done. So whatever we have discussed so far will not work if a proper checksum is implemented, right? Now let's see what we can do with the checksum.
This was a very, very unique case we came across. We actually, we did not have this in our use case. We usually have a test of use cases when we perform a black box exercise. This was a very exceptional case which one guy in our team thought of this somehow, and this actually worked. It wasn't supposed to.
Yeah, and to add in, what was happening was this was a byte box exercise in a rare case where we were in partnership with the payment gateway. And these guys actually ran out of money because they were frauded for about $1 million. And people were literally stealing money. They were losing money because people were placing orders, getting those orders. And I'm not talking about t-shirts, I'm talking about furniture. and these guys were getting scammed, and because we were their security providers, they reached out to us to do an audit to see what happened. So they gave us their code and we said, okay, we'll analyze, we'll try to find a bug in this. Now what's happening is they have implemented a flawless checksum, okay? You cannot, generally when you talk about checksums, there are other ways to bypass it, like maybe sending a null checksum, or maybe sending a checksum which is already authenticated, or checksum of some other transaction. There are a lot of ways, we'll have a look at them. But in this case, those scenarios were not working. Now, what happened in this scenario was when we read the code, when one guy in my team was reading the code, he saw how the checksum is being calculated. So if anybody is familiar with standard PHP or Python, you know to call data from an array, you generally either index it with 0 or 1s, with the numerical indexes, or what you do is call them with their string indexes, right? In this application, what these guys were doing was they were calling each parameter with the numbers. So parameter 0, parameter 1, parameter 2, and so on, then a salt, and then they calculated a checksum. So we thought it's interesting that they're not using the strings and indexes. What can be done when they are using indexes? Now what we did in this case was, in the last name parameter, so before the checksum is calculated, we have to do our tampering before the checksum is calculated. So what we did was, in the last name parameter, we entered a number, 1,000, okay? The price of the product was 1,200 euros, let's say. And we placed this order. Now, intercepting the request, we cannot change the value of the parameters. But what we did was, we moved the last name parameter in place of the amount parameter, and the amount parameter in place of the last name parameter. The checksum is still valid, right? The integrity is still not broken. But the amount, because we changed the location and the index changed, right? So it took the amount from the last name parameter, and 1,000 became 10 euros and 10 tokens. And the order, which was for 1,200 euros, was accepted for 10 euros. So this was one very interesting case scenario of bypassing the checksums. After reading this, now we check this scenario in every case we do. But before that, we were literally blown that some interesting case scenarios comes up when you do white box testing.
There was one more actually scenario which we came across, which nobody from our team could ever think of. So when you go to payment page, sometimes there is a small timer running out. Like you only have 2 minutes before this transaction expires, and you'll have to initiate the transaction again. So this guy in our team, he actually had his wallet. We had, basically, as we were doing black box, his wallet was in another room. So he went ahead, he went to fetch the wallet. And by the time he came back, the timer expired. And he saw that transaction was successful and the payment was complete automatically. So this was another very unique case where we saw that by default, if the transaction period has expired, your amount will be accepted and the transaction will be complete.
Because they were just checking the bin numbers, whether the card was valid or not, and the transaction doesn't go through. Now, these are the cases that you do not exclusively go and test for that. I'll wait for 2 minutes and see what happens. Nobody does that in the standard testing. And that is why when we talk about doing the testing of online financial systems, the first step that we say is to do a recon and map out every single way, every single outcome of a success and a failure transaction, and then test out each use case in each and every kind of that scenario. For example, tampering the parameters when the gateway is PayPal, and then trying it with something else. Trying it with bank directly, or trying it with your card directly. So there are different ways. So during the recon phase, you must map out every possible way that there can be a success transaction and a failure transaction and timeouts. So that's how you come up with all possible scenarios tested, right? So that's with request tampering. Coming to the next part, we have response tampering. A lot of people generally discard response tampering bugs. But when we talk about payment gateway implementations, financial applications, it's never a server-client communication. It is not that there is just one client and one server. No, there are always multiple things in between. And what happens is, when there are multiple things in between, the application relies on callbacks, JavaScript callbacks or WebSocket callbacks, which accepts response from the server, right? Now, in this case scenario, what's happening is, when you make a payment, and it goes to the payment gateway page or to the merchant page. The merchant sends back the response to a callback function in the main website where you made the payment, right? And response tampering can be very prominent here. So when in the first recon phase, we mapped out each and every possible success response scenario by doing a proper payment, what we start doing is trying replacing the response, making a failure transaction, replacing the checksum, replacing the successful code, replacing the response URL. And this is one scenario wherein we simply changed the URL of where the callback was coming. So once we failed the payment at the banking website, it was redirecting to failure.do with the code of 400. We changed it to 200, changed the response of the callback from failure.do to success.do. Now this JS, which is validating this entire incident, sees, okay, the response is as success.do, the code is 200, transaction gets accepted, right? So this is very, very interesting case of response tampering. And with this, we were able to purchase loans, like pay our installments for loans, buy SIPs, do a bit of stock trading. Can you imagine the impact of such things where you can buy stocks with like minimal money? You're not only putting that company at a loss, but you are damaging the market. Because if you're buying shares for lesser amounts, the market can change. And that causes a really, really massive impact. So that is response tampering. And yeah.
So yeah, now this is another very unique case which happened in this year only, I guess so. And this is one of the biggest shopping websites of Europe. And I was doing a bug bounty, and I think, yeah, I got paid around 2,500 bucks for like 3 bugs, which were all on the same request. So it was very simple. Basically not that simple. What happened was, when you try to shop on a website, you log in, you add items to your cart, and then you go ahead and add your payment details and check out, right? What happens in this case was, once you log in and select the items, it asks for your payment details, right? And what I noticed, after these payment details were added, the website actually sent a request. Now this request had a unique ID, which said card ID. Now I thought, okay, ID, let's try to tamper it. I started increasing the ID, and for some reason what happened was, basically changing the ID loaded somebody else's card information in my account. Not the entire card, but the last digits and whatever. And when I went ahead and placed the order was actually accepted. His card was charged, order was sent to me. This was one of the bugs. Now second bug was, what if, this is still detectable, the other person might cancel his card. And what if, he calls up and he says, I've not done this transaction, reverse it. My order will be cancelled. How do I still get the order? Right? Now, what I did, I made an account, I added a card into it, I made sure it's valid till the time the merchant validated it. Then I blocked the card. I called up my bank, I said, it's been stolen, can you please block it? Now, the card was blocked. I went through the same steps. I noticed my card ID. Can you go back a slide? Yes. So I noticed my card ID, and now shopping from the first account again, I added items to my cart, I went through the steps, and here I replaced it with my blocked card. The ID of the blocked card which were added in the second account. Now what happened was, the order was placed again, it was shipped, and the card was not even charged. So for some reason, the company was not validating the card again once it was saved. Now this was another case which was very, very unique, and we found that a lot of companies actually use Kibana to validate or view their logs properly. So in this case, this was an e-commerce website which was actually logging all the transactions which were happening through the users. Now, by default, payment gateways are not allowed to send the entire payment card details back to the commerce websites, right? It's by default policy does not allow them. In this case, while testing the e-commerce website, what we discovered was this Kibana instance. And while going through the logs of the Kibana instance, we saw that a particular payment gateway they use was actually returning the entire details of the card expiry date, CVV, as well as the customer's name in the logs.
You know, this is what happens when you don't have GDPR in Asia. The hackers they have a lot of freedom to hack. We as red teamers have a lot of freedom because we can literally hack it. During our normal exercises, we get inside employee emails. We don't read their private stuff, but we search for VPN passwords. So with GDPR, both of the parties, absence of GDPR benefits both of the parties in a negative way. Wherein these organizations are completely storing, this is not even GDPR, this is PCI DSS storing clear text card details in the database, which is completely invalid.
Both the providers were failing. The e-commerce website was actually storing it without knowing, and the payment gateway was returning it.
And
for some reason.
that's because they were recording that data as part of logs. So it's not in the database, but it's there in Kibana, right? And another case scenario, GitHub information.
Yeah, this is one of the recent ones we were doing for some client in Dubai. So what we found, when we do a black box, we actually look for, it's easier to find public information rather than going ahead and looking for a 0 day in a web application. So what we do is generally we look for company names, some sort of parameters we make up, we create a list of keywords, and we try to search the keywords, and we also look at employee credentials, employee names, and all that. So in this case, what we figured was there was this guy who used to work in this company. He left about a year ago, and he did some work. He was a developer, and we started looking around and looking at his emails. What we found was that this guy created some sort of code, and he hard-coded his credentials. Although he left the company, these credentials were still there.
And how we got access to these credentials? Anybody? PondDB. We digged out the email pattern of that organization, found its employee details, got the pattern that is first name dot last name's first character @company, searched it on PondDB, and got the password, logged into the GitHub account, and voila.
And we got access to the merchant PayPal account, which was still being used by the company. So please, guys, don't do that. If you actually leave a company, please don't
Yeah, and this is really common. People literally fork out the professional repositories of their organizations onto their private accounts. And when these accounts get hacked, we are talking about one of the largest food review and food delivery companies in India, where the developer's account was hacked and the entire source code was there. These guys downloaded the entire source code, ran a source code analyzer on that, found RCEs, found IDOs from the code itself, and ruined the entire organization just because the code was there on GitHub. So, that's why searching on GitHub is a very, very helpful thing while doing red team exercise.
Now, we showed you some of the ways, like tamper the checksum, bypass the checksum, tamper the amount, do a response hampering. But what if none of this works? What next? Now, this was a case where this was a website of a merchant, and so we tried all the different things, nothing worked. We tried tampering the payment, we tried tampering response and everything, nothing worked. So we thought, why not? We just went to the admin panel, tried to brute force the credentials, and we got in to the admin panel. Now, this panel had a unique feature. If a user comes in, puts an item in the cart, and leaves at the checkout, now you can actually go ahead from inside the panel and mark the order as successful. So instead of just paying for it, we went to the admin panel and we started marking the order as successful, which was actually shipped. So this was also a unique case.
Yeah, I think
now we'll
move on to patches. So when you talk about patches, we have obviously implementing proper checksums instead of using the indexes, using the proper numbers, the string indexes. Doing regular audits. This is the massive thing that people don't do, is that they do not carry out their bank audits. So fraud is happening since last 1 year, and they realize that these guys haven't done an audit in the past 6 months. And when they do the audit in 6 months, they realize, oh, we've lost $1 million. So regular audits is the most important thing when we are dealing with financial gateways, right? Of course, doing red team exercises and logical bug testing is very important. A lot of organizations simply don't do that. They assume that the VAPT team is enough to carry out all the tests, whereas logical testing is something that Burpsuit does not do. So missed out, yeah. That's missed out. And most importantly, when we talk about security of financial implementations, such as websites that provide services, is server-to-server check. It's called an S2S. What happens in an S2S is the moment the transaction is done, even when approved, the client, the web application, sends a request to the server to check if the request was successful or not. And then the server does a server-to-server check from the merchant, from the website to the bank. This is called an S2S. So once this S2S is done, at the end of the server, a hacker cannot tamper it, right? Unless he's there in your servers, of course, then you have no hopes. But if this S2S is successful, then only the order is marked successful. And this is the most basic implementation of patching this. Now, quickly coming to direct money sources and sinks, let's talk about what do we do with banks. So when we talk about banks, I do a lot of bank testing as it happily falls into my lap when doing testing because they're generally pretty complicated architectures. And these are some common scenarios that I try to look for. Either I gain access to people accounts or I exploit a flaw in the system wherein I can gain access from my account to their data, right? So let's move forward with this. OTP bypass is one very common scenario wherein you have two-factor authentication of any kinds, and you're able to bypass that. A lot of you would have already tried this out, like any application that does OTP-based authentication. You intercept the OTP checking request in your burp suite, send it to the intruder, maybe 6-digit or 4-digit OTPs. You run it at 50 threads maybe, and one of the OTPs get approved because they're not rate limiting. They're not checking how many times the OTP is being checked, right? And the OTP is maybe not getting expired properly. In those scenarios, OTPs can be brute force. Now, in this special scenario, what was happening was, before doing an OTP check, to generate an OTP, this application was first generating a token, okay? And across every token, you could only check OTP 3 times. Pretty straightforward, because if you do this with one token, the moment you try more than 3 tokens, the token gets expired, and you're not able to try it again. And that token gets blocked, and you get blocked for some time. Now, the problem was there was proper rate limiting on OTP checking, but there was no rate limiting in token generation. So before the OTP was checked, there was a request that is sent from the mobile application to generate a token. I simply generated 10,000 tokens and tried 10,000 OTPs. So this is again an interesting logical bypass scenario which worked in a lot of cases, right? Now, very interesting case scenario that I don't know if you would believe or not, but this is me testing a newer bank in our region.
Actual bank, guys.
Yeah, this is a real bank, okay? This is not hack me bank, okay? This is a real bank with real people's money. I go to the IDOR option, sorry, not the IDOR, the RD option, that's recurring deposits. Anybody who doesn't know recurring deposits is simply 1,000 euros get deducted from your account every month and they get interested. So what happens over here is, I see very interestingly now, these guys are using a very high-end, like Oracle-based banking infrastructure platform, which does not have any flaws, of course.
Finacle, I guess it was
Yeah,
Finacle.
it was Finacle, yeah. So above Finacle, they have built their own system, the UI. Now, what these guys do is, they put bugs in the UI. The infrastructure that they built over Finacle was flawed. So wherever I saw Finacle requests, I knew these were not, I could not tamper them. But certain kind of requests where the account number was actually going from the client side, what I did was, while creating a recurring deposit, I created a recurring deposit. It asked for my account number. In the dropdown, I chose my account number, intercepted the request, and put the CEO's account number as a POC, of course. So I put the CEO's account number. Now there's a 1,000 euro RD that gets deducted every month from the CEO's account. Now, because the RD is associated to my account, the CEO does not receive any notifications. He cannot cancel the RD because that's my RD. And every month, his accounts get deducted with 1,000 euros and gets credited to mine with that IDOR. And then this IDOR was not only there in RD, this was there in FDs, this was there in account information, credit card bill, credit card statement generation. So can you imagine that I can actually dump credit card information, credit card transactions of every user on the bank? So you can understand what happens with these case scenarios. And coming to this scenario, now you would say a lot of times what happens is, so buying SIPs, a similar case scenario where buying SIPs, you can purchase SIPs, and in this case scenario, what was happening was that you actually changed the client code. So when you're making a transaction, it shows you the client code, your client code. You change that client code to somebody else's account, and the order gets placed from his account. Now you will say, the payment has to be done by me. What's the impact? Imagine if I want to raise an SIP's value, I buy it out from 10,000 accounts. I'm actually damaging the market. So this was a very prominent impact which was accepted by their business team. The tech team they said this is not a bug. You are paying for the money. You are paying for the SIP. But I'm saying I'm able to buy SIPs from somebody else's account. That is tampering your backend analysis systems. So a lot of cases, you would literally say, how many of you have seen banking infrastructures where all the requests that are going are completely encrypted with AES? Or you have encountered with web applications wherein you open up your Burp Suite or Fiddler and you don't see the request because it's all encrypted with AES. The data is not there, the parameters are not visible. I'm sure you must have tackled these kind of scenarios. And this was in the case wherein this was one of the largest banks across Asia, I would say. One of the largest banks in Asia, which was encrypting every request with AES. Now, I tried a lot of things, right? So I tried to, read the JavaScript, try to find the AES encryption keys maybe, or try to bypass the encryption. I was not successful. But with Chrome, you are equipped with this wonderful, wonderful debugger, the Firebug. Even in Firefox, it's available. And what you can do with Firebug is you can actually set up listeners on variables. You can set up listeners on specific conditions. You can set up breakpoints and tamper with the variable values on the client side. So what I started doing was, when I went to that Get Account Statement page, on the button that says View Account Statement, I opened Inspect Element and added an on-click listener to it, saying on-click equals to debugger. So anybody who knows a standard bit of JavaScript knows that the moment you click on this button, the Chrome will pop up the console, and the debugger will pause the code right at that button. From then, I started going through the code line by line, see where it takes me. And this is how I mapped the entire JavaScript architecture. And I realized that there is a function that is being called before sending the request. That function takes in your request parameters and encrypts it. And then that request goes forward. So what do? You try to tamper the values before they are encrypted. So in this case, what I did was, I found that function. Now this code was minified and this was obfuscated.
Plus it had heartbeat checks.
Yeah, and there are heartbeats. So if you do not carry out your entire process in 5 seconds, you get logged out. Very common practice in banks, right? So in this case scenario, I really had to re-log in again and again and again and again, because the moment I spent more time on looking at the JavaScript code or as to what is happening, it logged me out. But I didn't lose hope. I kept trying, and then, as you can see over here, in this function, fetch intra-bene, this is basically fetch
beneficiaries.
Like intra-beneficiaries. Beneficiaries are the person you want to send money to. So this function, JavaScript function, I put a breakpoint in this JavaScript, and then I click on that button. It breaks over here, and in Chrome, you can actually see all the states and all the variables at that particular breakpoint. Here, there was a variable saying account number. What do? You change it to the CEO's number, right? And that's what I did. The moment I changed it, the application encrypted it with all its powerful AES shebang, which is unbreakable.
Unhackable.
Yeah, unhackable. And it got me the statement details and beneficiary details of the account number I provided. So in this case scenario, just because the developers thought that we have implemented state-of-the-art AES encryption, which in movies is unbreakable, then it cannot be bypassed. And this is what happens. People believe that you can hard code, you can harden the client side. No matter how much you harden the client side infrastructure, if you are not implementing server checks properly, you are doomed. It's not about when, it's about how.
Yeah. Do not trust the user ever.
Yeah. So I think This same IDOR I was then able to replicate on not only beneficiaries, I was able to fetch anybody's balance, I was able to add myself to their beneficiaries, I was able to get their card statements, I was able to block their cards, everything. This was vulnerable. Just because they thought that we have implemented AES, we cannot be hacked, right? So I think that summarizes the standard cases that we generally go through for testing money sources and money sinks, direct or indirect. Any questions? We have 4.5 minutes. Anybody would want to ask any questions? Can I please see hands?
No questions.
Everybody's going to be a millionaire now? That's the question. Well, we are running a company and you can never be rich that way.
Yes. Startups, right?
Any questions? Sorry?
Are we millionaires? Maybe, maybe not. We'll not tell a couple of hackers that, right? So we just taught you how to steal money.
So if you have any questions, you can, of course, reach out to us on email, Twitter, Facebook, or LinkedIn. All right. I think that sums up. Thank you so much for being a lovely audience.
Thank you, guys.
Thank you so much.
Yes. Thank you.